This is how to build a multi-agent system with watsonx.ai. Multi-agent systems work using React prompting. They turn your vanilla LLM into an agent, a system that can reason and complete tasks. Now, if we put a bunch of them together, you can build up a team of specialist agents to automate tasks. We're going to do that in exactly 15 minutes. But is this possible with all LLMs, and is there a framework that can help? We'll get to that. But for now, I've broken it down into 3 steps, and it begins with getting our LLMs ready. Alrighty guys, we've got 15 minutes on the timer. Let's kick things off. So the first thing that we need to do is import a number of dependencies. So we're going to be using Crew AI. It's a framework that allows you to do multi-agent systems or build multi-agent systems. So we're going to say from Crew AI, we are going to be importing the crew, task, and agent. And then we also want to give our multi-agent system access to some tools. So we're going to say from Crew AI underscore tools, import SERPA dev tool. Now, the cool thing is that there's a number of different tools as well, right? So if you wanted to use CSVs or docx files or GitHub or JSON or MDX or PDF, you got the ability to do that as well. Let me know if we maybe do that in another video. Okay, then in order to build our LLMs and interact with our LLMs, we're going to be using watsonx. So we need an interface to watsonx. So we're going to say from LangChain underscore IBM, we're going to import watsonx LLM. So that's going to allow us to build our LLM interface. And then we also need OS. So this is going to give us the ability to set our API keys for our environment. So we're going to do that first. So we're going to say os.environ, and then we want to go and set our watsonx underscore API key value. And we're going to set that to one that I got a little earlier. So I'm going to grab that API key from over there. Okay, and let's zoom out a little bit. And then we also want to set our API key for our SERPA dev tool environment. So this is actually going to allow us to interact with the net. So we can set that by running or passing through os.environ and then setting SERPA underscore API underscore key. And then we're going to set that to the value that you can get from SERPA.dev. So you can actually go and register for a free API key and get that up and running. We've got a bit of an issue there, so that's because of our quotes. Okay, cool. So we've now got our API key set. We've got a couple of dependencies imported. We're now going to create the first LLM. So we're actually going to be using 2 LLMs. I'll get back to that in a sec. So to create our LLM, we're going to create an instance of the watsonx LLM class. Then we need a couple of parameters or keyword arguments. So the first one is model ID, and we're going to set that to a blank key for now. We also need the URL. So because of the way that watsonx is spun up, we've got the ability to run this on a whole bunch of different environments. Plus, we've also got different multi-region availability. So if you wanted to go and run it in the US or in Europe or in APAC, you've got the ability to do that as well as on premises. Okay, so we've got model ID, we've got URL. We also need to specify the parameters for the model. So this is going to be how we actually decode. And we also want to be able to pass through our project ID. So you can actually isolate your machine learning and data science projects using watsonx.ai. So we're first up going to create a parameters dictionary. So this basically dictates how we actually go and decode from our model. So we're going to create a new value called parameters and set that to a blank dictionary. How are we doing on time? We've got 12 minutes. Okay. So our first value is going to be decoding method. And we're going to set that equal to greedy. So we're just going to use the greedy algorithm for now. And then we also want to go and specify max new tokens. So this gives you a little bit of cost control. So it dictates how many new tokens you're going to be generating. So we're going to grab that parameters value and set that into our LLM. And then we also need to specify our model ID. So our first LLM that we're going to be using is Llama 3 70B. So we've got the ability to actually go and change that. So you can see that we've got the ability to use Llama 3 70B instruct. Feels kind of weird. I know I've been using Llama 2 for so long now. So we're going to specify Meta Llama. And then it's going to be llama -3 -70b -instruct. And we also need to go and set the URL. So we're going to go to over here. So we've got the ability to copy this URL. So I'm just going to grab that and then paste this into my URL area. Let's save that so it should reorganize it. Okay, so I'm just going to get rid of everything after the .com, so we don't need that. Okay, so that is our LLM spun up. We also need to pass through our project ID. So again, that's available in a similar region. So it's available from your watsonx environment. So the project ID is just over here. So I've got a project ID I spun up a little bit earlier, so I'm going to grab that. and paste that in there. Okay, so this should be our LLM. So we've gone and specified our model ID. So we're going to use Llama 3, our URL, our params, and our project ID. Let's actually test it out. So if I run print llm.invoke and then I pass through a prompt, so this could be any prompt, but right now this is just a vanilla LLM. So I could go and say, who is Niels Bohr? You can tell I've been getting into a little bit of physics lately. So if we go and run this now, so the file's called agent.py. So to run it, we can run python agent.py. I'm going to pause the timer while we test it out. We have exactly 10 minutes left. Okay, all right. Coincidence? Yes. Okay, so if this runs, so I'm going to pause it while it's generating because that's a little bit out of my control. And let's see if we get a response to who is Niels Bohr. Crossing my fingers. Okay, take a look. So we've got a response. So this is coming from Llama 370B right now. So we've got a response. So Niels Bohr was a Danish physicist who made significant contributions to the development of atomic physics and quantum mechanics. He's best known for his model of the atom, which posits that electrons exist in specific energy levels or shells around the nucleus. Sounds pretty good. Okay, so that is our first LLM created. Now, I did mention that we're going to need a second LLM, and that's going to handle our function calling. So we're going to go and power on ahead. So we've got our LLM set up. Now we're actually going to go on ahead, create our second LLM, and then build our agent. So we're effectively on to part 2. All right, the time is at 10 minutes. I'm going to kick this off. Let's go. All right, so we're going to need to just copy this LLM over here. So we're going to create the function calling LLM. I'm going to speed up just a little bit, not too much. So we're going to create a new variable called function calling LLM, and for this LLM we're going to use a slightly different model. So we're going to use the IBM-Mistral AI, and we're going to use the Merlinite model. So Merlinite-7B. Okay, cool. So those are our 2 LLMs now set up. Now we're going to create the agent. Create the agent. And our first agent is going to be a researcher, but keep in mind, eventually you could have a ton of different agents. They could all delegate and interact with each other. So first agent is going to be a researcher. And we're going to create an instance of the agent. So there's a ton of keyword parameters that you need to pass through here. So the first one is the LLM. So this is going to be the base LLM that we use to do all of our generation. We then need a function calling LLM, and that is going to be our Merlinite model that we just set up there. So I'm going to paste that keyword argument in there. And then we also need to specify 3 additional arguments. So there's more than 3. So role, goal, and backstory. And I've pre-written those prompts, so we're going to spin those or pass those through in a second. We also want to determine whether or not we want to allow delegation. So eventually, I might do this in another video, but eventually you've got the ability to allow these agents to hand off to each other and just sort of delegate and work out which agent's going to be able to do the task the best. We also want to specify some tools. So we want to give our agent access to the net. And then the last thing is whether we want it to be verbose or not. So I'm going to set that to 1. Okay, so role, goal, backstory. So this basically dictates what our agent is good at. So our agent is going to be a senior AI researcher. The goal for that agent is going to be to find promising research in the field of quantum computing. And then the last backstory bit is going to be, so this agent's got a little bit of a cross collaboration between AI and quantum research. So a backstory is you're a veteran quantum computing researcher with a background in modern physics. Okay, so that's our agent. We now need to give it some tools. So tools, this one's pretty straightforward. So we're going to create a tool called search, and that's going to be equal to the SERPA dev tool. So this, I believe, inherits from LangChain. It allows you to go and search the net. We just need to grab that search value and pass it through here. So that is our first agent now completely set up. Now we actually want to go and fill this out a little bit more. So we want to give it a task. So create a task. And a task is effectively what we want our multi-agent system to do. So our task, first task, so we're just going to call it task 1, is going to be a task. And then the task is going to have a couple of things. So we need a description of the task. We need the expected output. How are we doing on time? 7 minutes. Okay, I think we're all right. We're sounding all right. We also want the output file. So this is actually going to output the results of the task, and then we want the agent that we want to complete that task. Okay, so the description, again, I've baked these a little bit earlier. So we're going to grab the description, search a net, and find 5 examples of promising AI research. I'm going to paste that into description, and I'll make all of this available via GitHub later so you guys can grab it as well. And then the expected output is going to be a detailed bullet point summary on each of the topics. Each bullet point should cover the topic, background, and why the innovation is useful. Our output file is just going to be the name of the output file that we want to output. So we're going to say task1 output.txt. And the agent that we want is not a string. The agent is going to be our researcher. So which agent that we want to complete the task. Now we need to pass through these tasks to the crew. So put it all together with the crew. So we're actually going to hand it off to a crew and let the crew run it. So we're going to say crew is equal to crew. And then inside of there, we want to specify agents. And initially, we're just going to have one agent, but we're going to come back to that in a sec. And then we also want to specify the tasks that we've got. So right now, it's just task 1. And then we want to specify verbose equal to 1. And then we just need to kick it off. So we're going to run crew or print crew.kickoff. Okay, all right. All right, I'm going to pause it. So let's actually go and run it. So I'm going to clear this for now. And we're going to run python.agent.py again. And all things holding equal, this should start doing our research. Let's pause it. All right, 5 minutes 32 on the clock. Let's see how we go. If this works, we should start this task. So search the internet, find 5 examples of AI research. You should see it making calls out to the net and us getting research back. So you can see that this has generated some action input. So it's saying to use the search function, so search query, and then run this command, promising AI research in quantum computing. And take a look, we've got some responses back from the net. So anything in orange is what we're actually getting back from the internet. So once it's collated everything it needs, it should generate the bullet point summary of the research that we want. So let's just let that run for a little sec. You can see that we've got a bunch of other research coming back there. And take a look, we've got our response back. So you can see that we've got all of our output down here. So here are 5 examples of promising AI research. So it's gone and done all of the research, and then it's decided that it's done. So the agent's now understood that it's complete because it's gone through its thought process, it's queried as much as it needs to, and it's generated its response. So down here, we've got 5 examples of promising AI research in the field of quantum computing. So quantum AI, quantum machine learning, quantum optimization, quantum RL, quantum neural networks, and we've got all of the responses. The cool thing is that it will output it as a text file. So if you wanted to go and use it, those are all of our bullet points. You can go and use that. I'll include that in the GitHub repo so you can see the responses as well. Okay, so that is, I'm actually going to save this as the first example so you guys can grab it because we're actually going to regenerate this in a second. So far we've gone and created one agent, one task, right? But this isn't really a multi-agent system. It's a single agent system. So what we now need to go on ahead and do is generate our second agent to be able to go and truly convert this into a multi-agent system. All right, we've got 5 minutes 32 left on the clock. You can see that. Let's go. Let's bring this home. Second agent. Okay. So what we're actually going to do now, let me zoom out a little bit. So you can see that we've got our first agent and task pair. We're actually going to copy this and I'm just going to paste it down here again. So we're now going to create the second agent. And it's pretty much the same. The only thing is that we don't need to give our second agent access to the net. So we're going to tweak this a little bit. So let me zoom in. All right, so we can get rid of this function calling bit, we can get rid of the tools, and this agent is actually going to be a writer. So we want this agent to actually write some keynote speeches for us. So we're actually going to pass through a different role, goal, and backstory. So I'm going to grab that out of here. So our second role is a senior speechwriter. So let's say that you're writing speeches for a prominent executive. You need to go and write some speeches. So the role is going to be senior speechwriter. The goal is to write engaging and witty keynote speeches from the provided research. I'm going to paste that in. And then the backstory is going to be you're a veteran. This should be tweaked a little bit. Looks like I just went and copied and pasted when I was writing. So you're a veteran quantum computing, I'm going to say writer with a background in modern physics. But again, you could go and tweak this a bunch more. But effectively, you could provide a bunch of background on how this person's a writer. Okay, so that's our backstory. Then we want to go and create our second task. Tweak this and let me know how you actually go. All right, so we're going to generate our second task here. So our second task is write an engaging keynote speech on quantum computing. So I'm going to paste this in the description. And then our expected output is a detailed keynote speech with an intro, a body, and a conclusion. So we're going to paste this in over here. Perfect. And then our second output file is just going to be called task2 output. Okay, so that is our second agent. So our second agent is a writer. Our second task is to get that keynote speech written. So it's almost like a sequential agent, right? So the first agent's going to do the research, find all the research. Second agent's going to step in and then convert it into a keynote speech. So we can actually go and pass through our second agent, which is going to be our writer down here. So this is what gives us the multi-agent feel, right? And eventually, once we allow delegation, if we did that in the next video, then we'd actually be allowed to, or be able to do all of the handoff. So our tasks, so maybe we convert agents into a series on the channel. You let me know in the comments below. Okay, so we've now gone and passed through our second task over here. We're going to pass through our second agent. We go and run this now, we should effectively go through that two-step process. So if we go and run this again, I'm going to clear this. And we should also get two outputs now, right? Because our second output file is called task2 output. So I'm going to run python agent.py. And I'm going to pause the timer. So we've got 2 minutes 43. This all blows up. That's how much time we're going to have left. 2 minutes 42 to solve this. All right. So let's let this run and see how we go. Okay, so you can see it's triggering the chain. It's doing the research again. So again, this is still the first agent. So you can see that the working agent is the senior AI researcher. We haven't got to the writer yet. Okay, so we're doing research. Okay, so you can see we've now, oh no, we're still doing research there. I thought we were finished. Oh, actually, no, we've got a bug. I've just realized. All right, I'm going to start the timer again. So we're at 2:41. So I just noticed that we were using the same agent. So inside of our second task, we actually need this to use the second agent, because right now we're just using the base agent. So we actually want this to be writer. Okay, we're gonna change the agent there, and then let's kick off our timer again. So I'm going to clear this. All right. It only took me 10 seconds to resolve. So we're at 2:22. We've still got time to debug, but we're probably going to speed through this. So editors, speed through this. Okay, so we're triggering our first bit from our senior AI researcher. Hopefully, once we get to that next debug stage, we're now onto our, what is it? What do we call it? Senior speechwriter is going to pick up from there. Okay. Take a look. So we've now successfully gone and handed off to the senior speechwriter. So this is our second agent kicking in. Hopefully they just write our keynote speech. It might be limited because we've only given it 500 tokens to write the speech, but you sort of get the idea. So fingers crossed, we now get a keynote speech written in under 15 minutes. Not too bad. All right, take a look. That's our keynote speech. Not too bad. All right, so we should, so we can see that we've gone and done the research. We've got our bullet point list over here. Bullet point list over here, and then we've got our keynote speech over here. So if we actually go and take a look, we've got our two outputs, so task 1 output and task 2 output. So this is the next set of output from the second run. So we've got all of our dot points, and if we go and take a look at our task 2 output, let's read a bit of our keynote speech. Ladies and gentlemen, esteemed guests and fellow innovators, I'm thrilled to be speaking with you today about the revolutionary potential of quantum computing. As we stand at the threshold of a new era in technological advancement, it is imperative that we explore the vast possibilities that quantum computing has to offer. I don't know how witty this is, but it is a keynote speech. In the realm of artificial intelligence, quantum computing is poised to unlock unprecedented capabilities. I'm going to put this all in the GitHub repo so you can read it yourself, but you can see that we have in fact gone and written a bit of a keynote speech. So we could definitely take this further, but for now, that's how to build a multi-agent system with watsonx.ai. I'll catch you in the next one.